Okay, college algebra, last video for the day and the week. 4.3 notes, page 5. At the top here, I attached the logarithmic rules from the bottom of page 4, and we're going to talk through them and see what they look like in a single problem. So you have two primary things you'll be doing during these problems, either expanding them to where every single number and thing has their own logarithm, versus condensing them where you take things that have their own logarithm and you put them all back together in a single logarithm. So if you are expanding, you're going to go from left to right. What that means is if you have a log with two things multiplied inside the log together, they each can have their own separate log with a plus in the middle. And this goes with the corresponding exponential property, where if you have a number raised to x plus y power, you can separate it, that kind of thing. Similarly, division becomes subtraction, but even more interestingly, if you have a log of one thing raised to a power, you can bring that power in front and multiply. So I did the first problem to see what they look like. So log base 6 of 7 times 9 was the original problem. Since there's multiplication inside, that looks like this first property, which means I can split them into two logarithms with the same base, and they each get their own. So it became log base 6 of 7 plus log base 6 of 9. Now, 9 is 3 squared, which means it's really 3 to the second power. So we can use this third rule that if there's an exponent, like a 2, we can bring it out in front and have it become 2 times the log base 6 of 3. Once everything's as expanded as you possibly can, you're done. So let's look at number 2. Log base 9 of x squared divided by y to the fourth. Okay, so this one is division, which is the second property. So just like this one split into 2 with a plus sign between them, with the log of the same base, this one's going to split into 2 with a minus sign in between them. So it'll become log base 9 of x squared minus log base 9 of y to the fourth. Generally speaking, if you have a big set of fractions, like number 3, anything in the numerator will have a plus or a positive in front of it. Anything in the denominator will end up with a negative in front of it. Now this isn't all we can do, because if we look at these individual logarithms, we see this is a log base 9 of x squared. This allows us to bring the 2 out front using that other property, so 2 log base 9 of x. And the y has a 4 exponent, so it can become minus 4 log base 9 of y. And this is your fully expanded form. Now let's look at number 3, a slightly more beastly problem. That's log base a of the square root of m times n times q divided by p squared z to the fourth. Okay, first off, we need really everything to have an exponent power, and square roots don't have that, but we can convert them. Specifically, before I break any of this apart, when something's under the square root, it's to the 1/2 power. This is a strategy that's going to help us, because if we bring a number in front, we don't know what the root is doing, but we do know what a 1/2 power is going to do when we bring something in front. Furthermore, other properties of exponents is that if 3 things are raised to the 1/2, that means they are all individually raised to the 1/2 power. Right now our denominator is just kind of chilling. There's not much else for it to do. Now, anything in the numerator we can break all of these apart in one step. Anything in the numerator will be positive. Anything in the denominator will get a minus sign, so it would be negative. So I'm going to break all of these in one step. This is log base a of m to the 1/2 plus log base a of n to the 1/2 plus log base a of q to the 1/2. Those are our 3 in the numerator, so they all got positives. P squared and z to the fourth are in the denominator, so they're going to get negatives. Minus log base a of p squared minus log base a of z to the fourth. Now, That's all in one step. You don't have to do it all in one step. You can break just the numerator and denominator into two and then split them further from there, but you don't have to do it. Now, what else you can do is, again, you have all those powers there. You can take them in front of your logarithms. So there's a 1/2 here, 1/2 log base a of m, and another 1/2 log base a of n, and another 1/2 log base a of q, and p has a 2 squared exponent, so -2 log base a of p, z is a 4, -4 log base a of z. Okay, so that one was a little bit more work, but it is all expanded, so we are done. So just be careful. You know, MyLabs Plus can be very extreme about making sure you get everything to the most simplified form, so if you miss even one thing, or even like from up here, you didn't turn that 9 into a 3 squared, it may tell you have the right answer, but it's not in the right form. So you just have to be careful with how you do your answers. Make sure you break down everything as much as possible. Now, condensing, you're going to go from the right side of the rules to the left side, because you're going to try to put everything back into a single logarithm. So let's look at number 1, log base 3 of x plus 2 plus log base 3 of x minus log base 3 of 2. So just like we tried to turn everything with a plus, or everything in the numerator became something with a plus in front of it, we're now doing the opposite. Everything with a plus in front of it's going to end up multiplied in the numerator. Now remember, this only works if you have the same base for the log, so you need to check that that's true. Anything with a minus goes in the denominator. So this becomes a log base 3. Inside all one logarithm, we have an x plus 2 and an x are in the numerator because they're both positive. The 2 has a negative, so it's in the denominator. And from here, all you really need to do is clean up the algebra. X plus 2 times x is x squared plus 2x, all divided by 2. So that one's not too bad. You're done right there. Now, what about the second one? 1/2 log base b of m plus 3/2 log base b of 2n minus log base b of m squared n. Like, these aren't even fully expanded. That's fine, we can still work with it. Okay, so the 1/2 power, so we undo the things that we did last before, like take the powers out, are the things we do first. So we need to put all the powers back in. So log base b of m to the 1/2 plus log base b of 2n to the 3/2, and then this last one, it doesn't have any power. Log base b of m squared n. Again, anything that's positive goes in the numerator, negative in the denominator. I'm going to also distribute this 3/2 power to both things. So we have log base b of m to the 1/2, 2 to the 3/2, n to the 3/2, over m squared n, because that one has a minus, it goes in the denominator. From here, we can reduce our powers. We have an m in the numerator and the denominator. I'm going to put the 2 to the 3/2 here because it's by itself. This is m to the 1/2 divided by m squared. That's really m to the negative 3/2. N to the 3/2 divided by n is n to the 1/2. Now, what do we do with negative power exponents? Really, they should go in the denominator. So this is 2 to the 3/2, n to the 1/2 over m to the 3/2. Now, you could turn all those half powers into square roots. I'm just not going to bother with it. I think this should be fine. Just be careful with your rules for exponents. They're still going to apply. Now, there's one last page in there, but there aren't any homework problems on it. It's kind of for fun, and we're just not going to deal with it. It used to be part of the curriculum. It's not. But this is all for 4.3, and that is the rest of this week. And we have one more week to go. I'll see you next week.